Hey everyone, and welcome. We're kicking off a brand new 6-part series where we're going to do a complete deep dive into the architecture of OpenClaw. It's a really fascinating project for a personal, self-hosted AI assistant. And trust me, we're going to dissect every major piece from this high-level design right down to its security. So let's get into it. So today, in part 1, we're starting right at the top. We're going to literally build out the high-level architecture so you can really understand the fundamental structure of the whole system. But first, let's just think about this for a second. What if a single AI could be the central hub for all of your conversations, across all your different apps, but running on your own hardware and completely under your control? Well, that's the core promise of OpenClaw. Okay, before we jump into any diagrams or technical stuff, we really need to understand the philosophy. The why behind OpenClaw is absolutely the key to getting how this entire system is put together. And that philosophy, it really rests on 3 core principles. First up, local first. And this one's a big deal. It's non-negotiable. Your data stays on your devices. That gives you total control and privacy. Second, plug-in first, which is huge. The system is designed to be modular from the ground up. Even core features are just plugins. This makes it incredibly flexible and super easy for anyone to extend. And third, provider agnostic. This means you are not logged into any single AI model. It uses this really clever adapter pattern, which acts kind of like a universal translator, letting it work with pretty much any provider you can think of. All right, so with those principles of local control, modularity, and flexibility locked in our minds, let's take a look at the blueprint. So, what is the high-level structure that brings these powerful ideas to life? The entire system is basically split into 2 main parts. A good way to think about it is like a brain and its body. On one side, you've got the gateway. That's the brain, the central control plane. It's the hub that gets all the messages, runs the AI, and manages, well, everything. Then, on the other side, you have the nodes. These are like the limbs and the senses. They're clients that connect to the gateway to give it local powers, like accessing your file system, running commands on your terminal, or even handling voice interaction. Okay, now let's really get into the details. We're going to build out the architecture of that gateway, the brain, piece by piece, right here on this whiteboard, so we can see exactly how it all fits together. So, we start with the absolute core component, this central box on our whiteboard, the gateway. This thing is the heart, the central nervous system of all of OpenClaw. So what's actually inside the gateway? Well, it's got 4 key services. First, there's the agent runtime, which is powered by a tool called the Pi framework. You can think of it as the conductor for the AI, orchestrating all the complex tasks. Then you've got the memory system for managing both short-term session data and long-term conversation history. The cron service is basically the system's internal clock. It handles all the scheduled and recurring tasks. And finally, the super important plugin registry, which is what dynamically loads and manages every single plugin. Right, so how does the outside world talk to this brain? Well, the gateway connects to an incredible number of inputs. We're talking over 15 different messaging channels. Things like WhatsApp, Telegram, Slack, Discord, even iMessage. They all just funnel right into the gateway. And on the other side, where does the actual thinking get done? This is where that provider-agnostic principle just shines. The gateway can send requests out to a huge range of AI models, Anthropic's Claude, OpenAI, Google Gemini, or even a local model running on your own machine through Llama. And when you put all of those pieces together, you get this. This is the complete high-level architecture. You have a central control plane taking messages from tons of channels, processing them with its core internal services, routing tasks to any AI model you want, and interacting with nodes for local capabilities. That right there, that's the big picture of OpenClaw. So, we've seen the blueprint. Now let's look at the foundation. What are the actual technologies, the bricks that make this whole thing possible? A quick look at the tech stack shows a really modern and robust foundation. It's written in TypeScript, which helps prevent a ton of common bugs. It runs on Node.js, it uses the popular Express framework for its web server, and WebSockets for that absolutely critical real-time communication between the gateway and the nodes. It even uses a library called SQLite Vec, which gives it a super efficient way to handle vector storage, which is a special kind of database for AI memory right there on your local machine. Honestly, if you only remember one thing from this whole explainer, make it this quote from the documentation. It just perfectly sums up the entire architecture. It's a distributed gateway plus node system built entirely around a plugin-first design. That really is the essence of OpenClaw.
So this high-level overview really sets the stage for what's next. We've established the two main parts, the gateway and the nodes. But how do they securely talk to each other over a network? Well, in our next explainer, we're going to dive deep into that exact topic, the communication and distributed protocol.
So I'll leave you with this final thought. What actually happens when the gateway, the brain, needs to tell a node on your laptop, one of its limbs, to read a file or run a command? We're going to break down that entire secure real-time conversation next time. I'll see you then.